Hello, my name is John Jacobs, W7DBO, and this is a presentation that I gave to the Utah Valley Amateur Radio Club recently, and I decided to go ahead and turn this into a narrated video in addition to providing the slide deck for those that attended. And I thought this would be a great way for those that couldn't attend or might just be interested in solar power in the field. So you can find these assets at my website at w7dbo.net. So when you first look at solar power in the field, you need to identify why are you doing solar and what are your goals. Just don't do solar power just to do solar power. Find out what goal you want to accomplish with it, and then that way you'll be able to be better directed on your purchasing decisions. Now you may want this for emergency preparedness. You may want it just to extend your operating time in the field, like in a soda operation where it's lighter to carry solar panels than it is extra batteries. Or this might be your only form of electricity. And so you need to identify what are your goals. For me and my family, with our little children that are digital natives, if we go into an emergency situation and they're stressed and then their devices stop working, their comfort items, then it becomes a higher stress level for us and them. So your goal may just be to keep your family devices running during an emergency or to be able to have enough power to do emergency communications. Or you may just want to look cool at camp. So this is my typical setup that I do for event support. This is supporting the Bear 100 race that's up in northern Utah in the fall. As you can see here, I have a Goal Zero 30 watt panels put on the Goal Zero tripod. And this was able to keep my batteries topped off while we still had sunlight. This was an overnight operation, so we ran on batteries and generators at night, and then in the morning we came back on with batteries once the solar power came back up. This is the same panel you can see here at field day. Once again, 4 30-watt panels tied together. This is a 50-watt panel that you can find typically on Amazon. They're kind of flexible, bendable. And then this bottom one is a 60-watt panel from Bioenno Power. Now this one's a PowerFilm. These are very handy, especially for soda operations, backpack operations, where you can just lay it down pretty much anywhere, and they perform best in rugged situations and lightweight situations and low light situations. They have some better technology that helps with that. As you can see here, this is that same 50-watt panel put together with a solar charge controller box, if you can see my mouse moving, and then also a battery box. So you have your combination of your solar panel, a solar charge controller, and a battery. And that's essentially the 3 components you need. And then once you hook your radio on or whatever you're doing to power onto your battery, that's your 4th component in the lineup. Now this is a nice little device. This is from Goal Zero. This is only a 3.5 watt panel, but it's enough to charge some AAA batteries or some AA batteries, and then in turn charge a cell phone. So this is not the, like I said, highest performing panel, but in a pinch, when it's in a small go bag or go kit, this might be all you need to do to get that cell phone back up online and make your communications wherever you are. So this is a box that I build with my company CommsToGo. This is a 20 amp hour Bioenno box, but inside it has a solar charge controller. So you can think of turning your regular power boxes also into solar boxes if you have the space, or you can use something like what Goal Zero has, the Yeti 400, that gives you the solar charge controller and the battery and the output devices all in one nice box. Or you can build what I call my kitchen in the sink box. This is pretty much everything you can think of put into the box. It's got the solar charge controller, it's got the battery, and it's got a whole bunch of other devices and options. So like I said, you have a solar charge controller. These usually come in a plate like this. So go ahead and put it inside an ammo can, put some plugs in it, and that will help you move the box around and be able to protect these devices. Here is another option. This is the Bioenno solar charge controller. Once again, just put in a simple ammo can with a Tenergy watt meter to tell you your input or output of your battery, and then just some power pole connections. Very easy to assemble, and gets your solar charge controller protected from the environment as you're working in the field. So this trailer is my go kit when I know it's going to snow. There's no sense in being miserable for event support. So as you can see here, I have my trailer and my truck. Now, what you want to typically do when you go camping, if you think about this, is some people will put panels up on the roof of their trailer. Well, when I go camping, or when I go something like this, my trailer, I usually nestle in underneath the trees so it's nice and shaded and not hot during the day. Well, I've just put my trailer with my solar panels on top into shaded environments. So what I figured out I would do is, once I got a shelf for my truck, is I put these solar panels on top of the truck. That way, wherever I go with the truck, I have solar power. And then if I am with the trailer, I can put the truck out in the sun to get the solar power. I can maneuver it where I need to be, and then I can put the trailer underneath the tree in the shade. So you can see here I have two Renogy 100 watt panels that can be either tied together to a single solar charge controller, or they can be separated out and charge two separate battery banks. And as you can see with this, when you do have solar power, you can afford the energy at night to be able to light up the area with your built-in batteries. So the first thing you need to do is identify your power requirements, because if you do not know how much power you need, then you're never going to be able to meet your goal of regenerating that power. So two things that will help you to identify your power requirements. First of all, on the left is from West Mountain Radio. It's the Power Check. This will track your power consumption over time and log it, and then you can plug it into a computer and see it on a graph and see how many amp hours you use, how many watt hours, and when your peak usage was. And you get a lot of information from that. Now, you can also use a much cheaper item called the Tenergy watt meter, and I'll include the link to this without power poles in the description below. You can get it for about $15, $20 on Amazon without the power poles. Now, the only caveat with these is it will tell you your time and your amp hours and your watts, but the minute you power it off, it loses all data. So before you power off, make sure you track and record what your information was. And so once you know what your power requirements are, you'll better be able to identify what your solar panel needs are to be able to match your power requirements. Now, this is from Bioenno Power, and I'll include a link to this in the description below, a PDF document. They have two documents. One is a field day, a 50-50 duty cycle battery runtime chart, and the other one is a 2080. Assuming that you're using the battery, or you're transmitting 50% of the time, listening 50% of the time, assuming that your radio receives on 5 watts. So these are things that are unique to you. Your power requirements are unique to you because of you have a different setup of radio. You have a different setup of accessory items, the way you operate. All things are unique to you. So you need to find out what your individual power requirements are based on your setup. So this is an average of, if you transmit on 5 watts QRP, you're receiving on 5 watts. If you have their BLF 1203 battery, which is a 36 watt hour battery, you get 7.2 hours of runtime. If you take that same battery or a little bit more and you go up to 50 watts, of course you have to buy a bigger battery to be able to get the amp draw. You have to go up to 180 watt hour, and that gives you 6.5. So that gives you a rough estimate of your operating requirements. But like I said, you want to meter it and check it based on your individual needs. Now, one big thing you can do to reduce your power requirements is identify areas that are your battery hogs. Like for this example, you see quite often people will take laptops, which has a DC battery and operates on DC. Then they use their DC to AC wall connection, and then they plug it into a DC to AC inverter. So what you've done is you've gone from a DC laptop to an AC connection back to a DC battery, and in the meantime losing massive amounts of efficiency. Whereas you can find for most modern laptops a power box that will use DC to DC and up voltage it to the right voltage. So this is one way you can reduce your power requirements. So you need to look across the line of everything you use and identify, before you spend all that money on those solar panels, figure out first, can you reduce your footprint? And then you'll save quite a bit of money and space when you look at solar power in the field. Now, this is a graph of a typical sealed less acid battery. What you see here, and I'll kind of move my mouse around because these numbers will be a little bit too small to read. These are amp hours across the bottom. This is voltage across the left. So this red line is your voltage over time. So it starts off at a little above 12 volts. Oh, sorry, I will go back there. So it starts off a little bit above 12 volts. And then, as you can see, this is what a typical signature you see of an SLA or AGM battery. It's a constant downward voltage drop until the point where it drops off below the voltage requirements we have. Now, if you look at this same graph, only this is with a LiFePO4 battery from Bioenno Power, you can see volts on the left, amp hours on the right. So this is volts over time, giving you your amp hours, and you can see this is this nice constant voltage throughout the life of the battery until it slopes off of the last 10-15%. So one thing you can do is, before you spend a lot of money on solar panels, you can look at upgrading your battery to something like the LiFePO4 battery from Bioenno Power, which I recommend, and that will help you need less solar panels because you have better efficiency in your batteries. So let's talk about the benefits to solar. You can do extended operations. You can continue to go and go and go, whereas a generator will eventually need service, will eventually need fuel. It's easy to use. There's less moving parts. You'll find with generators that there is maintenance required and downtime, whereas the solar panel is just pretty much a plug and play. It's lightweight and portable. Depending on the type of solar panels you get, you can be very portable with them. And then it gives you the tactical advantage. And what I mean by this is, especially in an emergency situation, you might not want to advertise that you have electricity. Solar panels give you the silent way to be able to generate power during the day and not advertise that you have electricity. This was an issue in New Jersey after the superstorm and hurricane came through. People had to stand over their generators in pitch dark outside on their porches because their generators were running in the middle of the night, and it was literally a beacon to all the bad guys that you have power and you have an operating generator. And so this gives you a tactical advantage in such situations like that. Now, let's talk about the components of a solar power system, and it's important that you do not shortcut any of these sections. You have your panel. Your panel connects to a solar charge controller. This solar charge controller is basically the negotiator between your battery and the panel. It accepts the voltage input and amps from the panel, and then it gives the battery what it needs. Just like you would not plug your battery directly into an AC wall outlet, you have a battery charger and a battery tender. That's exactly what the solar charge controller is for solar panels. It's the tender of the battery. It identifies when the battery wants full charge. It identifies when the battery wants to go into a float mode or a trickle mode. It also negotiates between the solar panel and the battery to make sure that the panels do not drop the voltage of the battery, as may you get a cloud pass over. And then your last step is you go from your battery to your radio. Now here's where like we've talked about, you don't want to shortcut the system. You don't want to go direct from solar panels to battery, because that's just like plugging in straight electricity uncontrolled into your battery. Same thing, you don't want to go from solar panels directly to your radio. That would be a disaster. You don't want to go from panels to solar charge controller to radio. Because the minute a cloud comes over, your voltage is going to drop and your radio is going to drop out. So your battery, think of it as a large capacitor or reservoir. It's going to ride out those low voltage moments you have with your solar panel and give constant, even voltage to your components. Now, panel construction. There's 3 different types of panel construction you'll find for portable solar panels. They're the aluminum ridge ones, where everything is encased in some type of aluminum or metal ridge. There's a soft canvas, which usually folds up or rolls up. And then you have these flex panels. This is a 100 watt flex panel. This has some holes in it. It's meant for riveting to, say, top of RVs or boats. Or I just use it because you can just throw it on the ground in the field, and if someone walks on it, it's not going to cause much damage. Material type, there's monocrystalline, polycrystalline, and amorphous thin film. Now, monocrystalline you'll be able to tell because the corners are notched. So when you see a panel, you can tell right away it's monocrystalline because of the notched corners. That's how they come in the process. Polycrystalline is usually less efficient than monocrystalline. Polycrystalline is also more susceptible to heat. So that's something to keep an eye out for. So overall, when you're looking at budgeting for panels, typically monocrystalline is going to be the better performing panel. However, with that being said, you could get a very poorly constructed monocrystalline panel, and a polycrystalline could actually perform better. So you want to look at the spec sheets and look at the reviews of people talking about the panels. Now, amorphous thin film, this is not new technology, but it's actually coming back around and working quite well with PowerFilm and their technology in being able to roll up solar panels with canvas backing. Now let's look at the specifications and kind of walk through a typical solar panel. This is the 60 watt panel from Bioenno Power. Maximum output 60 watts, maximum voltage 18 volts, maximum current 3.4 amps, open voltage 22 volt, and they say you could put this in a series or parallel if the same type. So you want to make sure with your panels that it's going to direct you, the panel construction is going to tell you whether you should connect this in series or if you should connect this in parallel, or if it does not matter. But it's always important to remember, never connect multi-brand panels together. You want to stay with the same brand and the same type to be able to provide consistency in your electrical connections. Now, when you ask how do they discern the 60 watt, and at what point are you going to get 60 watts out of this panel? Well, maximum output is calculated by maximum voltage, 18 volts times 3.4 amps is maximum voltage, maximum current equals maximum output. Now, highly likely with us living in North America, we are never going to see a maximum output of 60 watts. But it's important to always know that maximum number because you do not want to accidentally overload your solar charge controller if you happen to get into perfect light conditions. Now, your typical solar connection you're going to see, this is different from the amateur radio world. We're used to power poles and different type of Molex connectors. This is called an MC4 connector. It is a sealed double locking connector. They usually have a male and a female, and they're polarized separately, so you cannot connect your male or female into each other and cross connect your power polarity. So this is typically what you find with the solar world is you'll start seeing these MC4 connectors. These are quite easy to assemble once you have the right tool. Now, a thing you can do also is I do this, I 3D print these type of sundials, and I'll put the description or the link below if you want to 3D print your own, or if you would like to go to eBay and get one. What this is this is a little stickum that you put on your solar panel, and you can see here, I'll move my mouse around, you can see the sun is coming through not center. There's a little divot in the print that tells you your center. And so when you're trying to align your solar panels for maximum efficiency, this little solar dial sits on there and tells you if you're aimed properly at the sun. This works quite well for sun ovens also. So let's talk about the solar charge controller. You need to know that solar charge controllers have to have battery chemistry specific. Just like you would not take a seal less acid battery charger and plug it in to a lithium battery, or you wouldn't take a LiFePO4 charger and plug it into an SLA for your typical AC charging. You need to make sure your solar charge controller, like I said, it is the battery charger, so it needs to match the chemistry of the battery. Now you also need to match the voltage, battery voltage. So if it's a 12 volt, 24 volt, you need to make sure whatever battery voltage you have, that your solar charge controller matches that voltage. And then once again, we talked about maximum load current and input voltage range. You need to make sure that your solar charge controller can accept the panel. Some of these smaller ones, like this excellent one from Genasun, they have less amperage ones. They have one down to 5 amp, which means you can't load it up with 300 watts panels. You need to be more cognizant of that. So this is a typical solar charge controller. Genasun makes a great one for different battery chemistries and different amperes. And it is RF quiet, which is excellent for HF field work. Now, if you want to be able to increase the capacity of your solar charge controller, you can go to not from 12 volt to 24 volt, which typically you don't see this in the field unless you have a permanent installation, say, in a comm trailer. But that is something you can do to increase the capacity of your solar charge controller, is jump up to a 24 volt battery bank system. Now, using the West Mountain Radio computer battery analyzer, you can also use this to analyze solar panels. And one thing you find with solar panels is the harder you work them, they actually will go down in efficiency. So as you can see here with this chart, watts on the vertical on the left, current in amperes on the right, you can see how as you start putting a load onto this solar panel, so the battery is pulling power from the panels, you can see it kind of hits a peak and then it drops off dramatically, almost to the point where you're getting almost no production out of the solar panel. So what this considered here at the top of this peak that I'm circling around with my mouse is considered multi-power point tracking. Now the solar charge controller will scan, and once it realizes that it's getting less performance out of the solar panel, it will back off and regulate the amperes draw, the current, to match this multiple power point tracking, this peak. Now, as conditions change with light, this will change. So it's constantly scanning and making sure that you're getting the best efficiency out of your solar panel. So when you're looking at picking out a solar charge controller, keep that in mind, that a multi-power point tracking, or MPPT, if it says it has that technology, you're going to get better efficiency out of your panel, because like I mentioned in the beginning, it's going to be negotiating the best possible electricity from those cells. Now, specifications, let's look at a Bioenno Power solar charge controller. System voltage, it's a 12 or a 24. So you know you have options with this. Panel input range can go anywhere from 12 volt to 50 volt. Charge current 20 amp, it's going to push 20 amp, and the rated load current is 20 amp. So then you need to do the quick math and find out exactly what type of solar panels can I put with this and how many. And so you want to make sure that you always don't overload your solar charge controller with too many panels. Other items to consider, if you have a partial shade issue, a lot of times with solar panels, if a piece of the solar panel, say a corner, gets shaded, the whole system will shut down. It's based on how they've wired the cells in that panel. So keep an eye out for that. Test it. If you find that if you cover up 2 or 3 cells, all of a sudden it shuts down, then you know you have a partial shade issue. The Renogy ones that I have on the truck, I found that I can partially cover a little bit of the corners to be able to bracket it down to my rack. But if I cover up one whole row entirely, say with a 2x4, the panel does stop working. So you need to keep an eye on that and understand. Now, PowerFilm has done a great thing because they have military spec requirements. They've actually, and maybe I'll try and find a link to this, they shot a hole in one of them and it still performs. So you got to keep an eye on, like with PowerFilm, if you know you're going to be in if you're going to be in shaded environments, like I said, tactical advantage, you're not want to be standing out in the field with your panel, then maybe you need to look at something like PowerFilm. Heat exposure. So ironically, and I have a goal 0 panel that says do not expose to direct heat or direct sun, which is ironic because it's a solar panel, but heat exposure does lessen the performance of the panels. And so you need to look at your panels. What are they backed with? Are they hot? Are they laying on top of the hood of your car? Is that car causing heat? So try and keep these panels as cool as possible. And then also solar charge controller RF hash. I mentioned that with Genasun. You don't really hear that. With other solar charge controllers, especially the cheap ones coming out of China that are multi-branded through Amazon, they will produce RF hash. Now, most of the time you're going to get RF hash when the solar charge controller is cycling to trickle or float the battery. So if you don't normally hear that RF hash on current heavy charge. So if you do get RF hash on your bands, then you need to be able to just unplug it or put it in, turn it off, put it in standby mode, make your contacts, and then when you're not using those more sensitive bands, lower bands such as 80 meters, then you can go ahead and just turn back on the solar charge controller when you're not needing that RF issue. Then also low light performance. Panels will perform less, of course, in low light. That's obvious, unless you have something like the PowerFilm that has worked on doing some technology to help that. So let's go ahead and look at a graph of what's going to happen with low light performance. The top line, so at the bottom, my mouse is moving across current in amps. The left is volts. This top red line is an 85 watt panel faced directly into southern exposure sun. And you can see the power draw it has until it drops off. Now, this other red line that comes here and drops, this is that same panel only facing north with indirect light. And so you can see that indirect light is not going to get you any sort of output. So when you're doing your panels, you need to realize that you need to keep them pointed directly at the source and be able to know that you're just not going to be getting performance out of these panels if you don't get them in optimal conditions to point towards the sun. Now, lastly, before we wrap up, this is the most important thing, if you can learn from this presentation, is the proper boot up sequence for your system. You first connect the battery to the solar charge controller. This gets the solar charge controller powered on, and most solar charge controllers are negotiating with the battery. Are you 12 volt or are you 24 volt, and what is your situation? Then you hook up the panels to the solar charge controller. Now, the disaster comes when you hook up the panels to the solar charge controller, and then the solar charge controller is not powered up, and it doesn't know the type of battery, and it misreads the type of battery, or misreads the voltage of the battery, I should say, and then it causes damage to your battery. So always your boot up sequence: battery to solar charge controller to panels. Now, given that, let's go ahead and talk about the shutdown sequence. The shutdown sequence is just reverse. Take the panels off the solar charge controller, and then take the solar charge controller off the battery. And then that way you'll successfully power on and power off your devices. I hope you have found this presentation helpful for solar power in the field. You can find the downloadable assets at w7dbo.net. Thank you for watching.